Hello friends, today we are going to the discussion of molecular orbital diagram in titanium H2O6 complexes. In these complexes, the central metal is titanium and its surrounding 6 water molecule or aqua ligands. The atomic number of titanium is 22 and the oxidation state of titanium is +3, the +3 oxidation state, and therefore the electronic configuration of titanium is 3d1 4s0, and this 3d1 4s0 electron configuration, and therefore the titanium electron configuration, one electron is occupied in 3d orbitals. Okay, and the 6 ligands donates tail electrons which are occupied in A1G, T1U, each orbitals. This each orbitals to their pair of electrons. This is the tail electrons are. These tail electrons are occupied in ligand group orbitals, and these ligand group orbitals is known as A1G, T1U and EG orbitals. Here the construction of molecular orbital diagram, on left side the atomic orbitals of titanium T2G, EG, A1G and T1U. That means 3D, 4s and 4p orbitals. 3D orbital is T2G and EG orbitals. 4s orbital is represented as A1G and 4p orbital is known as 4 T1U orbitals. And on right side the ligand group orbitals is 6 ligand group orbitals A1G, T1U and EG orbitals. Okay, and both are the central metal atom and its surrounding group of the ligands, aqualigands, are placed on left and right side, which are combined to form a metal orbitals. These metal orbitals, the middle part is the molecular orbitals. This is the molecular orbital. The molecular orbitals are in capital letter. Okay. This left side atomic orbitals of titanium and right side the atomic orbitals of ligand group orbitals. These in above the atomic orbitals, molecular orbitals is known as the anti-bonding orbital, and lower below the non-bonding orbital, below the T2G orbital is A1G, T1U and EG. This is known as the bonding molecular orbitals. Here first the lowest energy orbital is the A1G orbitals, and in atomic orbitals A1G is here, in ligand group orbitals A1G is here. To overlap the A1G atomic orbitals of titanium and A1G atomic orbitals of ligand are overlap to each other, then to form a bonding molecular orbitals of A1G and anti-bonding molecular orbitals of A1G. Here the A1G is combines with A1G, then to form bonding molecular orbital and anti-bonding molecular orbitals is titanium, and this is the H2O ligand group orbitals. A1G combines with A1G are overlap to each other, then to form a bonding molecular orbital of A1G and anti-bonding molecular orbital of A1G. This is the bonding molecular orbital of A1G and anti-bonding molecular orbital of A1G. To connect the A1G and A1G, and therefore here we connect the A1G from this ligand orbitals are connected. A1G and A1G are connected to bonding molecular orbital A1G and anti-bonding molecular orbital A1G. Next energy is the T1, T1U. Here T1 is uh, present in ligand group orbitals, also T1 in atomic orbitals of titanium. Here are connected. This T1U is connected to T1U, and here also starting from this point is connected to T1U, and this is the antibonding orbital T1U also connected through this point, because these orbitals are same energy or equal energy. Okay. The next energy orbital is orbitals. Okay. This is starting from this ligand group orbitals, and this is the each orbital here starting. Okay. This is bonding orbital and anti-bonding orbital. This is also starting to form a molecular orbitals. This is the A1G, T1U, EG, bonding orbital, T2G and non-bonding molecular orbital, EG star, antibonding, A1G star antibonding, and T1U antibonding orbitals. Okay. Total number of electrons in metal orbital and ligand orbitals is 13 electrons. Okay. 1 electron from titanium and 10 electrons from the ligand group orbitals. These are 10 electrons. Okay. These 13 electrons, out of 13, 10 electrons occupied in bonding, and 1 electron occupied in non-bonding. Here 10 electrons are there. And therefore the A1G, the capacity of A1G orbital is maximum 2 electrons, because single is generated. Here 2 electrons are occupied in A1G orbital because only one orbital. In T1U 1, 2, 3 number of electrons, number of orbital is 3, because T for triple it is generated. Here for single it is generated means only one orbital. T for triple it is generated, that is 3 orbitals, and therefore the capacity of T1U orbital is 6, and therefore 6 electrons are occupied in 3 orbitals. Each orbital contains pair of electrons. Therefore 6 electrons occupied in T1U orbital, and EG orbitals, each for double it is generated, and therefore 2 orbitals, and therefore the maximum capacity of EG orbital is 4 electrons, and therefore 4 electrons are occupied in EG orbitals. Okay, and therefore 10 electrons are occupied in bonding molecular orbitals. A1G 2, T1U 6, and EG 4, and therefore 10 electrons occupied in bonding molecular orbital, and remaining 1 electron. This 1 electron is occupied in this is the T2G orbital, non-bonding orbital. Okay, this part is the bonding, this is the non-bonding, and this is the anti-bonding, and therefore according to the crystal field theory, the T2G to EG, the difference in energy between T2G non-bonding orbital to anti-bonding EG orbitals. This is known as is delta T, difference in energy between T2G to EG, and therefore when the absorption of light, the electrons are transferred from T2G orbital to EG orbital. These electrons are excited to higher energy level, that is anti-bonding EG orbitals. The excitation of electrons from non-bonding T2G orbital to anti-bonding EG orbitals when absorption of light, H mu, when absorption of light at the this absorption of light is this is the 2 3 20,000 23,000 per centimeter. This is the wave number. Okay, this is the this is the photons of absorption of light. Then okay, you occupy the electrons in T2G orbitals. Okay, the absorption spectra of titanium H26 complexes is the is delta O or delta P value is this is the transfer of electron from T2G to Eg star, that is antibonding orbitals. Okay, and therefore they this is known as a DD transition. The excitation of electron from T2G to Eg star. This is known as a DD transition. Means T2G to Eg transfer of electrons. T2G to Eg transfer of electrons, and therefore from this MO diagram, these are the central metal atom is titanium. Atomic number is 22, and the oxidation state of titanium is +3. Nature of ligand is weak field ligand, that is apo ligands, and the number of electrons is donated by the apo ligand is 10. The total number of the electrons from central metal atom and its surrounding group of ligands is 13. Out of 13 electrons, 10 electrons are occupied in bonding orbitals and 1 electrons transferred into non-bonding orbitals like T2G. Okay, and then the nature of the ligand is weak field ligand. Weak field ligand. Nature of ligand is the weak field. Then the color and the absorption spectra is in part titanium is the violet, purple or violet color. Reddish purple, reddish purple color. Reddish purple color, and the maximum absorption at the maximum absorption at 20 per centimeter. Maximum absorption at 20,300 per centimeter. Therefore, maximum absorption of absorption at is absorption or spectra. Spectra is 20,300 per centimeter, and excitation or transition is DD transition. This is the DD transition takes place. DD transition is the excitation of electron or transfer of electron from T2G orbital to Eg star orbitals. Okay, and charge transfer, there is no charge transfer takes place. Or charge transfer transition at higher energy levels like 27,000 to 30,000 per centimeter, and therefore this is charge transfer transition. Charge transfer transition at 27,000 per centimeter to 30,000 per centimeter. And next parameter is the magnetic property. Here, due to unpaired electrons in non-bonding orbitals, it acts as a paramagnetic nature. The paramagnetic nature is due to unpaired electrons in T2G orbitals. Okay, this is about the MO diagram form. From this MO diagram, you can to explain the nature of ligands, the spectra of the complexes, what type of transition takes place in the in complexes. Also, to show the charge transfer transition by using the, or to explain the charge transfer transition by using the MO diagram. Also, You can also to explain the magnetic properties. It is dimagnetic or paramagnetic in nature. Total is unpaired electrons or paired electrons. Unpaired electrons, it is always paramagnetic nature, and dimagnetic nature is always all electrons are paired in T2 orbitals and H star orbitals. All electrons are paired, and this is the dimagnetic in nature. Okay.